Welcome. All right, today we're going to make our first node and we're going to do our first publisher, first topic publisher in Python. Before this, I had to rework a few things in this virtual machine. So I did remake the package from previous movie. I called it class workspace. I think that's what I called it in the movie, but if I didn't, that's what happened. Anyway, inside class, I created a new package. So we look and we go to source. Then I created class example. I believe in the movie I called it first example. You feel free to use that one. Inside class example, I created a basic node like I did in the movie. So the hello.py is my basic node that just says hello from class example. I also created a new Python file called dicepub.py. So how you do this is you go gedit space or navigate to this folder in your package. Again, remember I have workspace, source, package, and then inside that package is package, so to speak. Then I'm going to gedit the name of the script I want, in this case dicepub.py. If I want to keep my command line, I can do space and sign, and then I hit enter. So go ahead and create open up or create a new Python script. I obviously have it open, so I'm not going to do that. The other thing, once that opens, it'll open up gedit. We'll talk about yours will be blank. That's fine. We'll talk about this code line by line. The other thing you want to do is open and go to your package folder and open up setup.py. It's the other one. I don't know if you actually need to do those includes or the depends we had in the package XML. So far I haven't needed to do that. So I go to setup.py. The one thing we're going to change is right down here you'll have your basic script. I believe in the movie we made two scripts. Go ahead and add another one, dicepub equal, then the name of your package, class example, in my case, I think your case was first package, then the Python name without the .py, which is dicepub, and colon main. Make sure there's a comma after the first one. That's all I had to do to make this work. I didn't actually need those depends that we added in package XML. Of course, I do have this workspace already sourced in bash rc. So if you haven't sourced or haven't modified bash rc, or if you're using Windows, you'll have to make sure you source this workspace. Okay, now as I go through this, please feel free to pause the video. I purposefully do not include code because I want you to type it out. I found that you will retain it better and you'll just understand it better. Now keep in mind, everything in this unit is based on Bloom's taxonomy, the first three levels of Bloom's taxonomy. One of those levels is memorization. Most of the content we talk about today needs to become second nature. Maybe you have to look up one of these commands once in a while, but you should basically have a pretty good idea of what's going on. So this is also going to be a node that only publishes. So there's two parts kind of to a node. There's the node itself that's doing something specifically to the robot system you're trying to create. Then there's the main function, which is going to kind of determine how this node operates. So this particular node is going to use a timer. So I'm going to go through this line by line, but essentially this is the constructor in Python. This creates a timer that every 10 seconds I'm going to call this function self.rollen. In order for this to work, I have to use the function rcl.py.spin and pass in what node I want to spin. This basically says, okay, if I'm getting any subscribers, if I'm using any timers, if I'm using any rate.sleeps, which we'll talk about later in the class, this is what updates them. If you don't have this line, this node will stall out. So in this particular case, every 10 seconds, all this node is doing is just going to publish a topic. We'll talk about that in a moment. Again, we're going to go line by line. But I want you to understand that there are several different ways this main function can look. And this is an example of just creating a publisher. All right. Now, first things first, we're going to import RCLPy. This is the ROS2 version of ROSPy. We're going to import random to get a random number. And we're going to say from rclpy.node, import node. This is going to be the class that our class inherits from. So that's why we're inheriting node. And from standard messages.message, import int16. Now wait a minute. I haven't said anything about standard messages. Where did I pull this out of? So this is an example of needing the ROS command line. So say I do ROS2 interface list. These are, again, are all the different ROS messages that I have on the system. Yours should be fairly close to this one. I might have a few more because I did a full install with ROS on this one. But if we look here, we kind of go through here, we can see standard messages, and then we have an int16. Now if I'm sending a number between 1 and 6, I don't need a 32 or 64-bit int. In fact, I could use an 8-bit int. I should probably use that one instead. Let's do that. Let's do that. That'll be better. 8 and 8 and 8. Again, I'll go through this line by line, I promise. Say, okay, well, I see where you got the message from. So this is the topic. This is the type of message that my topic's going to be sending. But how do I know what's inside there? So this is where I can say, okay, ROS2 interface show slash standard messages slash message slash int 8, capital I, 8. I have a space. Oops. There, didn't need the front one. Didn't need a forward slash in the front. So here it says int 8 data. Now this means when I create my int 8 object, I'm going to have a variable, a public variable called data at the top. So whatever I need to do is essentially set my .data variable of my int 8 object to whatever value I want to use. So that's how I kind of came up with what message to use here. Now, again, this part of it, this command line part of it, needs to become second nature. If I say we're going to use a float, if we're going to use a double, if we're going to use a some sort of sensor message, you should be able to figure out how that message and that topic is composed. Luckily, with the exception of one of my messages, everything's going to be built in, so we're not going to be making our own messages in this class. But this part, what I did here, should become second nature. All right, so let's do this line by line. So this is the message type that I'm trying to get, that I want to send. Our objective here is to roll a 6-sided dice every 10 seconds. So this is my definition of a class in Python. This is how I inherit in Python. So we're going to be inheriting from node. This is a little different than, say, ROS1. This is, in my opinion, better because this is more OOP. So ROS1 is very functional. This is much closer to OOP design, I would expect. So then we have define underscore underscore init underscore underscore self. This is Python's constructor. This gets called when this object's instantiated. Python, similar, well, it's not the same, but Python has to pass in a reference to itself for all of its own class functions. Likewise, if you're going to have a class variable, it needs to be defined with self. Now, I would highly, highly recommend that you put all, in fact, just make this a rule, put all class variables, define them at least with an initial value inside the constructor. There is no, there is no this. So we don't have public self.myData equals 0. We don't have any of that in Python. Now you don't have to define class variables in a constructor. However, if you try to use a class variable before you've defined it, you'll throw an exception. That's why I recommend defining all of your class variables inside a constructor. So if we pass in self, because it's Python, we have to pass in a reference to the object, the instance of the object it's part of. We're going to call super init, and this is going to call the init constructor for node. This is the class that it inherits from. And we're going to pass in the name. By the way, when you call these functions, these class functions, you do not need to put the self variable in explicitly. If I wanted, like for down here, if I wanted to, I could go dp.rolem, and that's how I would call it. So you do not have to actually type in the self or pass in its instance. That will be handled for you. You just have to have it as a parameter. So here we're calling the parents class constructor and giving it the name of the node. Then we're going to create our publisher. This is the object that's going to publish out the information and allow other people to hear it or read it. So self.pub, feel free to use whatever variable name you want. Again, this is going to be a class variable. It needs self in front of it. Self.createPublisher. Wait, where did this function come from? This function's inherited from node. So this is where the OOP comes into play. Back in ROS 1, it was just create publisher or publisher instantiate, something like that. This is actually creating a node under this object. So self.createPublisher, we're passing in the message type int8. We're going to give the topic a name. So this is the thing that I have to subscribe to in order to get my information. Then this is the queue size, which for this class we can just remain at 10. 10 should be fine. Self.lastRoll equals -1. This is initialization. I recommend initializing values that you might need to check to invalid value, so you know in case you never received a message. In our case, it doesn't matter. This is publishing, but this would be a good way to know that I've not received a message. We'll use this again when I go to the subscriber topic. Then we're going to create our timer, self.timer, self.createTimer. Again, OOP here, which is a good reference. I'm going to say 10 seconds, and you're going to call self.rolem. We do not need parentheses because this is a function pointer. So every 10 seconds, this function will get called. Again, feel free to pause the video if you're falling behind. So, and also another thing in Python, I think I mentioned before, do not mix tabs and spaces. So if you're going to use space to define a new scope, like a function or a while loop or if statement, only use spaces. If you're going to use tabs like I do, only use tabs, but do not mix the two. So now inside our function rolem, we're going to say self.lastRoll equals random.rand int 1 through 6, inclusive for rand int. I believe rand in Python is exclusive, but for integer it is inclusive. I have these messages printed here as I was debugging a little issue. I'll come back to this. This is a great technique. This is a great technique to use to debug. If you're running your code and your code just stops, you're not getting any errors, you're not getting syntax errors, anything, then try this out and figure out where the code's stopping. Now, the thing and the reason I left them in here is once you've solved the issue, make sure you remove them if they're just debugging statements like they are. This can interfere with the timing, and I have seen this interfere with timing in robotic systems because printing out to the console is actually very time costly. So make sure you take out your print debug statements. and actually make sure you take out any of your commented code as well. So then as I create my message, message equals int8, I instantiate int8, message data equals self.lastRoll. So here's where I'm taking that message data that I looked at the command line, message.data is going to equal that variable I just rolled, and then self.pub, which is my publisher I created in my constructor, .publish my message. And now this will send out whatever random dice roll I rolled. It's going through our main here, and these messages are probably okay to keep because they're not inside a loop and are giving a status of the system. So here we do rcl_pi.init args equal args. This is basically boilerplate code. The args will come back into play when we use ROS parameters, which we'll talk about later. I have a default setting args equal none here because that means if I do not have any arguments, there'll just be a none value. I print instantiating dice. I instantiate dp equals dice pub. That's instantiating this class, an instance of this class. Calling spin. So rcl_pi.spin dp. This is what allows a timer to roll. This would allow all callbacks. If I had any callbacks to happen, this was actually what would allow rate to function, as we'll talk about, as I'll show you later. You can ignore this statement. That statement is no longer true. Again, I was debugging some stuff. So after this spin is done, which essentially means the ROS died or ROS stopped working, or I hit Control C, it will dp.destroy node, and then it will say rcl_pi.shutdown, and this will remove this node from the ROS system. This, once again, is just invoking in case I invoke it directly from the script directly without going through the ROS2 run. This will say, okay, go ahead and call main. We will not be invoking it through this method, but it's good to have there, just in case you need it for debugging. So we're going to save that. Again, pause the video if you need to. I'm going to minimize this. And now we're going to go back up to our workspace, do calcon build. Again, if I get the warning, it's not the end of the world. I do ROS2 run class, what was it? Class example. If I hit tab, you'll see that I have dice pub and hello. We'll do dice pub, hit enter. So say instantiating dice, calling spin. Now this is every 10 seconds. So I do ROS topic, no, excuse me, again, there I go again, ROS2 topic list. So you see now we recognize that there is in fact a dice roll. So ROS2 topic echo / dice roll, and every 10 seconds. All right, we're back. Sorry about that. So what it was I was echoing from a previous run, and that echo still had that my dice roll was type 16, so there was a conflict in the ROS system. When I disabled that echo, it started working. So here we see ROS2 topic echo dice roll, and every 10 seconds I get a new dice roll. This probably worked out of the box for you because you didn't have the 16. So that's what happened in mine. So this would be an example of sending out information on ROS2. Again, we're going to compose the message or instantiate the message, add our data to it. Even if it's a complex message, we just add our data to it and then we publish it. So with that, we'll leave this video off. I want you guys to work through this, and then we will go forward and talk about subscribers next.